Today let us look at coordination compounds. What does the name suggest? Coordination, which is formed through coordinate covalent bond. So, one who donates a pair of electrons is called a donor. It is also called a Lewis base, and it is called a ligand in this chapter. A ligand. So, who will donate a pair of electrons? Those who have pairs of electrons, molecules with a lone pair of the central atom. NH3, it has a lone pair of electrons which is likely to disturb the bond pairs. And molecules with a lone pair on the central atom and all anions, negatively charged ions, can act as ligands, donors, Lewis bases. I want to remind you once again, what is Lewis theory in short? I think almost in every class we are using this. Lewis theory in short. Base is a substance which donates a pair of electrons to acid. So, let us straight away take a complex and let me describe that. CONH3 6 times 3 plus. First, the name. It is called hexamine. Look at the spelling, AMM. Ammonia is called amine in a complex. Hexamine. Cobalt 3. Hexamine cobalt 3. What is this 3? This is called the primary valency. Primary valency of the complex, or primary valency of the transition metal. Primary valency 3. And how is this complex formed? Whenever I ask you this question, you have to think like this. How is this complex formed? I tell you why is this complex formed later, but as of now, how is this complex formed? Cobalt, after losing 3 electrons, cobalt after losing 3 electrons accepts, donor is the word, donor, acceptor. For a dative bond, you have to use these two words only especially, donor, acceptor. Like ionic bond, we use the words lose or gain. Sharing is the word for covalent bond, and donor, acceptor for coordinate covalent bond, dative bond. Cobalt, after losing 3 electrons, accepts 6 pairs of electrons, 6 lone pairs of electrons from 6 different ammonia molecules. Why is it done like this? Why is cobalt taking so much of trouble? What do you mean by a complex compound or a coordination compound? Complex by definition is big. It's a huge molecule with so many members of the team. Look at the atomic number of cobalt, 27. The elements present in D block, they are called transition elements. Of course, all of them are not called transition elements. Some elements of 2B, zinc, cadmium, mercury, of course, they are not called transition elements. That's a different matter. So, the D block elements are at the center of the periodic table. Means they are not close to noble gases. Look at the nearest noble gas, 18 argon, 36 krypton. And if an element wants to attain noble gas configuration, an element like chlorine 17, nearest noble gas is argon 18. So, if an element wants to attain noble gas configuration, it either gains or loses electrons. But in the case of cobalt, it is neither here nor there. 1836, it has to gain 9 electrons and get a charge of -9 units and lose 9 electrons either it should become plus 9. Both the ways it is difficult. Cobalt cannot gain 9 electrons. So, these complexes are formed to attain noble gas configuration, if not directly, at least indirectly. And I am telling you, not all transition elements are successful in behaving like this. Maybe sometimes noble gas configuration may not be attained, that is not a rule. But the effort is get as many bonds as possible and get your positive charge neutralized by donors.